Hi everyone, this is the Lesson 4 Extra Practice ECON315 Guided Study Group session. Just as I do every week, I'm going to go over some problems. This week there's a lot, and there are a lot of math and graphs associated with this week because you were just introduced to budget constraints. So I'm going to get started right away. So number one is about budget constraints. Sally has no other source of income except for her job at a coffee house that pays $6.50 an hour. Since she is such a good worker, her boss lets her choose how many hours she wants to work each week, as long as it is between 1 and 20 hours. Assume there are 80 possible hours in a week that can be devoted to leisure or work. So graph her weekly budget constraint. So the most important thing to realize with budget constraints is your x-axis is going to be your total amount of hours, not just how much someone is working. So this x-axis, as we build it, is going to be 80 possible hours. And what I like to do, and like what I've been taught, is to have kind of, I'll call it a double x-axis. So it's easier to see which hours are leisure and which hours are work. So I'm going to start drawing it to make a little more sense. So graphing her weekly budget constraint, we're just going to have an XY plane, which we can just start off like this. Okay, and then labeling the axes, I'm going to start with the x-axis like I said. I'm going to put leisure first because usually this is measuring from 0 to infinity. We're going to be measuring leisure. And then under it, I'm going to put work because whatever hours we're not devoting to leisure, we're going to devote to work. So in this case, it said she had 80 total possible hours. So this would be 0 and 80. And then under it, if she's working 80 hours, if she has 80 hours of leisure, that means she's going to be working 0 hours. And then over here, the opposite, if she has 0 hours of leisure, she's going to be working 80 hours. So I think making this double x-axis makes things a little bit easier in interpreting what we're supposed to do for these problems. And then on the y-axis, we're going to put income. Important point is that it's income and not wages. Those are two very different things because what we'll see is our wage rate is going to be the slope of this budget constraint. So make sure you're labeling those correctly when you do these problems. So anyway, it said that she has no other source of income except for her job at the coffee house, and it pays $6.50 an hour. Like I just said, that's going to be our slope. And since it's possible for her to work since there's 80 possible hours in a week, what we have to do is to find our y-intercept, in this case on the income axis. We have to calculate how much income she would bring in if she worked 80 hours, which we can just do from 80 times 650. And that gives us 520. So we know that this y-intercept is going to be 520. And then we can just draw a line to connect this to our x-intercept. Oh, our x-intercept is 80 hours because if she works 0 hours, she's not going to make any money. So those are the two ways to find the intercepts. And then we can see that this slope is going to be, in this case, negative 650 because it's downward sloping. But the slope is always the wage rate, and then our intercept for the y-axis is going to be if they were to work all the possible hours, and the x-intercept is going to be 0 at whatever the amount of total possible hours are. Hopefully you're able to follow along with that. So we graphed weekly budget constraint. That was part 1. Part 2 says, how many hours must she work to cover her weekly rent and food expenses that total $91 a week? So her total expenses equal $91. So all we have to do is find how many hours she needs to work at a wage rate of $6.50 to cover $91. So we can just set up a simple equation of 91 equals 650 times x. And in this case, I'm going to have x equal the number of hours. So then solving for this equation, we can just divide each side by 650. So we get x equal to 14. So we know for Sally to cover the $91 of expenses for that week, she needs to work 14 hours. And then finally, number 3, it says, if Sally gets a raise to $7 an hour but chooses to still work only enough to cover her rent and food expenses, now how many hours must she work? So in this case, our wage rate is increasing, but we set up the equation the same way. She still only wants to cover $91, but she's working at a wage rate of $7 an hour, and then we're trying to find the number of hours, which is x. So we can set up this equation, 91 equals 7x. Dividing each side by 7, we get x equal to 13. So we can see with the increase in her wage rate, she is working less hours, which should make sense. So that was all of number 1. It was really straightforward, a simple start to these problems. But we're going to introduce a couple other things that make things a little harder, but I have full confidence that you'll be able to do them. So let me go back to the PowerPoint. That was number 1. Number 2 was worker compensation programs. So consider a workers' compensation program that replaces 50% of a disabled worker's previous weekly salary up to a maximum of $300 a week for as long as the worker is out of work. As soon as the individual works even 1 hour, all benefits are taken away. Jim and Ted both worked for the same firm and were injured in the same accident. Both worked full-time, 40 hours a week prior to the accident, with Jim earning $20 an hour and Ted earning $10 an hour. So how much in weekly workers' compensation benefits is each worker entitled? So what they're asking is we need to look at what they were originally making weekly and then take 50% of that. But there's a salary maximum of $300. So if that 50% of what they were usually making is over $300, they're still only going to be receiving $300. But we can figure that out with some math. So going back to this whiteboard, I'm just going to write down some good information. So they tell us that Jim works $20 an hour and Ted works $10 an hour. So full-time, they were each working 40 hours a week. So the first thing we needed to find was how much they'll be compensated. So like I just said, we need to find out how much they were making weekly beforehand. So I'm going to start with Jim. All we have to do is multiply the number of hours they worked, which is for Jim is 40, times their wage rate of $20 an hour to get $800. So that is how much they were making weekly. Now, this compensation program covers 50% of it, but up to a maximum of $300. So we see that half of 800 is 400, but this is above the maximum. So what this means is Jim is going to receive just $300 a week while he's out of work. And we can do the same exact thing for Ted. Ted was also working 40 hours, but at a wage rate of $10. So he was making $400 weekly. This program guarantees or gives out 50% up to $300. So we can see that 50% is $200, and this doesn't go over the maximum, so he's just going to be compensated $200 a week. It's not that the program isn't that everybody gets $300. What they're being guaranteed is half of what they were making, but up to a maximum of $300. So that was all that was needed for number 1. Number 2 says, what percentage of each worker's previous weekly salary is replaced under the income management program? So what they want to know is how much of this compensation that we just figured out is part of their weekly salary. So we're going to be looking for this percentage. So for Jim, we know he's being compensated $300, but he usually makes $800. So we create this fraction to look at what specific percentage he's being compensated. So we can see that 300 over 800 gives us 37.5%. Now you can do the same exact thing for Ted. So he's being compensated $200, and he was originally making $400 a week. So we can see that he's being compensated 50%. And last but not least, it says, assuming both Jim and Ted are free to return to their previous jobs at their previous salaries when healthy, how many hours must each person work per week to replace the income they were receiving while collecting disability? So what this is saying is they're returning to full work, they can work at their normal wage rate. How many hours do they need to work to cover what they were being compensated? So Jim was being compensated $300, and he is now back working at a wage rate of $20 an hour. And again, I'm going to denote X as the number of hours worked. So we can just set up this equation of 300 equals 20X to see how many hours it would take at a wage rate of $20 an hour to get us to a $300 total. So then dividing each side by 20, we see that X equals 15. So Jim is going to need to work 15 hours to cover his compensation benefits from when he was out of work. And then for Ted, he was being compensated $200, and now that he's healthy, he's back to working $10 an hour. So then setting up the equation same way, we can see that Ted needs to work 20 hours a week to cover all of his compensation benefits from when he was out of work. And that is all of number 2. So this one didn't have any budget constraints. It was just looking at compensation programs and using some algebra. I think the important thing with this problem was knowing how to set up these equations and figure out how everything is related to each other. So the next one, income effects. John is a college student who works part-time at a campus restaurant. He is paid $8 an hour and has no non-labor income. Assume there are 168 possible hours in a week that can be devoted to leisure or work. So again, this one does have the setup of budget constraint. So of course, number 1 says graph his budget constraint and label the utility maximizing outcome if John opts to work 40 hours a week. So again, they said that he was paid $8 an hour and that there are 168 possible hours. And then it said that can be devoted to leisure work, which we already know. So graphing his budget constraint, set up the same as last time. So we have income on our y-axis, and so we're going to have this double x-axis of leisure and work. So they told us there's 168 possible hours in a week, so we know this range is going to be 0 to 68 for leisure, and then the opposite for work, 168 to 0. We know that our x-intercept is going to be at 168 because if he's at 168 hours of leisure, he's having 0 hours of work, meaning he's not making any money, so his income is going to be 0. And then we know for the y-axis, our y-intercept is going to be the total amount. If he were to work 168 hours at a wage rate of $8 an hour, his total income would be $1,344. So we know that that's our y-intercept. Then we can just draw a line to connect the 2 points. So it then said, graph his budget constraint and label the utility maximizing outcome if John opts to work 40 hours a week. So this is where that budget constraint, this double axis idea comes in. So if he's working 40 hours a week, I'm going to label that right here. That means he has 128 hours of leisure. Make sure you don't put 40 like over here. It's very different between leisure hours and work hours are two very different things. So make sure you're paying attention to the instructions, which one it's saying. In this case, it said he's working 40 hours. So he's working 40 hours out of 168, meaning he has 128 leisure hours. So what this is going to do is we can just follow this vertically up to where it lies in the budget constraint and create a point on the budget constraint that will then tell us what our income is. So we can calculate this by if he's working 40 hours at $8 an hour, 40 hours at $8 an hour, we can see that his income, utility maximizing income, is $320. And that is all that's needed there. So number 2 says, suppose John's parents decide to send him $100 a week. Graph his new budget constraint. So this new amount of $100 a week is not related to his wage. So this is his non-labor income. So this $100 is present regardless of work. So what this is going to do is shift up. So what this is going to do is tell us that even if John works 0 hours, he's still going to make $100. So this is going to shift his budget constraint up by 100 at every single point. Because then if we look at the y-intercept, if he works 160 hours, he's still receiving $1,344, but then he can add 100 onto that to give us $1,444. So like I said, it shifts the entire curve up by $100. And then we can see that at 0 hours of work, he's receiving $100 still. So it creates like this ledge kind of budget constraint, or like it has, yeah, like a ledge or a cliff or something. So that's all that was needed for this, just recognizing that with the $100 of non-labor income, it shifts it up. So then finally, how many hours will John now have to work to maintain the same weekly income as in 1? So this is part 3. So his weekly income was originally $320. So this income now is made up of his labor income, which is 8 times the number of hours worked, plus the $100 he's receiving from his parents, which isn't dependent on the number of work hours. So we want to find the number of hours that give us $320, but factoring in that extra $100. So we can just set up this equation like I just did and then solve for it. So subtracting 100 from each side, we get 220 equals 8x. And then dividing each side by 8, we get the number of hours equal to 27 and a half. So we can see from this extra boost in income, John has to work way less because he was originally working $40 and now he's working 27 and a half. In case you wanted to see where this was on the budget constraint, it would still be at 320, but you could graph it this way. So this would be 27.5. So we can see that his income isn't changing at all, just his number of hours from this shift in the budget constraint. So that is all of number 3. So number 4, income maintenance program. A government income maintenance program guarantees an annual income of $6,000. Moreover, for each dollar earned by recipients, benefits are reduced by $1. So what will be the size of the subsidy earned by a household that earns $2,500 per year? What will be that household's total income? So this one isn't budget constraints. It's this subsidy program. So this program guarantees $6,000, but what they're saying is for every dollar you earn, your benefits are reduced by $1. So this household earns $2,500 per year. So if they're earning $2,500, that means their benefits are reduced by $2,500. So we can see that their benefits are going to be $6,000 minus $2,500, which equals $3,500. And then their total income is going to be their income plus whatever their benefits are. So that equals the $2,500 they're already receiving plus the $3,500 in benefits from the subsidy program. So that gives us a total income of $6,000, which was guaranteed. So that one was pretty straightforward. And then the second one, it changes things up and it says, the government then alters the program. Now individuals are still guaranteed an annual income of $6,000, but benefits are reduced by 30 cents for each dollar earned. So what will be the new size of the subsidy earned by a household that earns $2,500 per year? And what will be the household's new total income? So they changed the policy a little bit, saying that for every dollar they receive, benefits now only go down by $0.30. So to find how much this subsidy is, we just need to take 30% of 2,500, which equals 750. So we know from a household that's receiving $2,500, the benefits are going to decrease by 750. So their subsidy is going to be 6,000 minus 750 to equal 5,250. Now, that's the size of the subsidy. And then they also ask us what the total income is. So like I said last time, their total income is going to be how much they're making already plus this subsidy. So they're already making $2,500. Then we can add in the subsidy of 5,250 to get us a total income of 7,750. So thinking about it, this makes sense. If their benefits are going down by less for each dollar they make, they should be able to qualify for a higher subsidy, which then with the higher subsidy increases their total income. So sometimes when you look at these problems, you have to do all the math with it, but then you can take a step back and think intuitively about how this makes sense. Because sometimes your math might be off, and then you might have to look back and be like, wait, that doesn't look right. And then you can see the math error and fix it to something that does look right. But my piece of advice would just be to pay attention to your math and make sure things are logically making sense as you do them. So I think that was all of number 4. Yep. So we can move on to number 5. So welfare and child support. So we're back to some kind of, wait, have we done welfare yet? Maybe not. Anyway, welfare and child support. So Jennifer is a single mother offered a job at $15 an hour. She has $100 of non-labor income per week obtained via child support. So they give us her wage rate and then some non-labor income, which is from some welfare. So number 1, Jennifer's mother watches the baby for free while she works. What is her total weekly income if she works 20 hours a week? So we can see that her total income is going to be her income from labor, which is the amount of hours she's working times her wage rate, and then adding in any welfare benefits, which she does have. So solving this for the math. So the wage rate was $15 an hour. And then she has $100 of non-labor income. Which I'm just going to make a note is from welfare. So like I just said, number 1 says, what is her total income if she works 20 hours a week? Because her mother's watching her baby. So this is going to be the number of hours she's working, which is 20 times her wage rate, 15, and then adding in her non-labor income of 100. So this gives us 20 times 15, which is 300. 300 plus 100 is 400. That is all for number 1. Number 2 says, as Jennifer's baby gets older and more mobile, the baby is too much for her mom to take care of during the day. As a result, Jennifer must now use market child care, costing $25 a week in fixed costs, transportation costs, and $10 an hour in variable costs. How many hours must Jennifer now work to obtain the same weekly income is before when she had access to free childcare. So this one, we obviously are going to have to put some kind of equation together to figure out how many hours she needs to work to get back to this $400. The problem is she's now incurring some costs from not having free childcare. So when they say fixed costs, they're going to be independent of the number of hours working. So starting with this equation, she's going to have to incur fixed costs of $25 a week. So I'm going to start off with minus 25. And then she's going to have variable costs of $10 an hour. So variable cost means they are dependent on how much you're working, because think of it as she's paying by the hour. So like this $25, she's not paying by the hour. And then the $10 of variable cost, she is paying by the hour. So this is going to be dependent on the number of hours she works. So it's going to be minus 10x. But then we can also, so this is going to affect how much money she's making. But then we can also put back in the amount of money she is making still from working. So she's making $15 an hour still, so we can add in 15x. And she's still receiving $100 of non-labor income. So this equation we're making is just the combination of all the costs and benefits she's receiving. So the benefits are going to be her earnings from working $15 an hour, which we see as 15x, and then $100 from welfare. Then she has the fixed cost of $25 a week, and then the variable cost of $10 an hour, and that puts together this equation. And then we want to set that equal to $400 because that's the amount of income she's trying to get back to. Then we just need to combine like terms and solve for x. So I'll start with the constants of the equation. So $100, so 100 minus 25 is 75. So we have 400 equals 75, and then 15x minus 10x equals 5x. Then we can subtract 75 on both sides to get 325 equals 5x, and then dividing by 5 on each side, we have x equaling 65. So we can see that if Jennifer wants to put her child in childcare but still wants to make $400 a week, she's going to have to work 65 hours a week. So again, the most important part about this one was being able to put this equation together. I think my explanation was a little weird at first, but hopefully I clarified it for you. You just have to take into account all the costs and benefits she's receiving and put that on one side of the equation, and then the income she's trying to make on the other side of the equation. And always think of x as the number of hours she needs to work. So then for part 3, it says if the child care center does not allow one to pay by the hour, but instead requires one to pay for full-time care, which is 40 hours a week, in order to have access to any care, what will Jennifer's income be, assuming the same fixed and per hour cost of care as in 2, if she, 1, decides not to work at all, and 2, increases her labor supply to 40 hours a week? So this one gives us a lot of information. So I'm going to do this by looking at the scenarios instead of all the given information. So it says, what would her income be if she doesn't work at all? So if she doesn't work at all, she's not making any earnings, but that means that she has the time to look after her child so she doesn't have to pay for childcare. So for part 1, all she's going to be receiving is the $100 from welfare, and that's it. And this is if she doesn't work at all. All she'll receive is the $100 from welfare because she's not making any earnings. And then number 2 says, what would her income be if she increased her labor supply to 40 hours a week? So she's not allowed to pay by the hour anymore. She has to put her child in full-time care, which for them is 40 hours, meaning that Jennifer would have to work 40 hours a week, or she's able to work 40 hours a week if the child care center watches her baby for 40 hours. So all we have to do is keeping the same equation, because it said the costs are still the same. We just have to put in 40 for X and then solve income. So income, which I'm just going to say is M, is going to be negative 25 minus 10 times 40 plus 15 times 40 plus 100. And we can just solve it out. So we can see that this becomes negative 25 minus 400 plus 600 plus 100. So 600 plus 100 is 700, 700 minus 400 is 300, and 300 minus 25 is 275. So what we see is that if the daycare makes her pay for full-time care, which is 40 hours a week, she can work 40 hours a week, but now she's only making $275 in income from this new policy. And that is everything that was needed for number 5. So then, finally, I think we're on the last one. So number 6 is all about child support assurance programs. So consider the economic situation of Tatum, a single mother with one daughter, Blair. Tatum is free to work as many hours as she would like at $10 an hour. Additionally, should she qualify, Tatum may also collect welfare benefits. The welfare system in Tatum's state guarantees her a weekly income of $300, and benefits are reduced by $1 for each dollar Tatum earns in the labor market. Finally, Tatum has been awarded $100 a week in child support by the courts. She lives in a state with a child support assurance program. So this given information is kind of a combination of all the different kinds of problems we've done. So there's a lot of components of it, but I think if we just take it step by step, it'll be pretty easy to get through. So what is her income if she does not participate in the labor force? And how much of this income is from child support and how much is from welfare? So, of course, I'm going to write down all the given information to make things a little bit easier to look back at. So, the wage rate is $10 an hour. And then she has a weekly income. So she has, so I'm going to put welfare. The welfare system guarantees a weekly income of $300. But we know that for every dollar she's making, benefits are reduced by $1. And then finally, child support has awarded her $100 a week. So number 1, after looking at all this information again, number 1 says, what is her income if she does not participate in the labor force, but how much of this is from child support and how much of this is from welfare? So it doesn't work in the labor force, don't have to worry about the wage rate and earnings. So this welfare program guarantees her $300, but this subsidy is given, this welfare program guarantees $300, but they're only giving her the amount, I can't explain this. For every dollar she receives, her benefits are reduced by $1. So that's going to affect how much welfare she's given. So what we know is she's already making $100 from child support, meaning that she can't meaning her benefits are reduced by $1. Okay, so she's making $100 in child support. That amount is subtracted from the welfare she's able to receive. So $300 minus $100 gives us $200. So she's receiving $200 from welfare. And then, like I said in past problems, her total income is going to be what she's making already plus the welfare. So she was already given $100 in child support plus the $200 in welfare. So her total income is $300. And we know that $100 of that income is from child support and $200 of that income is from welfare. And that was all that was needed for that one. That I somehow couldn't explain, but I figured it out. Hopefully you were able to follow along. So number 2 says, with the child support assurance program in effect, how many hours may Tatum work before she no longer qualifies for any welfare benefits? So she's eligible. That looks close enough to eligible. So she's eligible for $200 of welfare, which we just said in the past problem. Since she's already making $100 from child support, she's eligible for $200 of welfare. So this is asking how many hours may she work before she no longer qualifies for welfare. So we know that with every dollar she receives, benefits are reduced by $1. So if she's working $10 an hour, we can just set up this equation of $200 equals 10x, x equaling the number of hours worked. So what this is saying is, how many hours does she have to work before she's making the $200 that she's eligible for, which would the $200 that she's eligible for, therefore not making her eligible for welfare anymore. So then we can just solve for this. So x is going to equal 20 because 200 divided by 10 equals 20. So x equals 20 hours. This is saying that if Tatum doesn't want to be eligible for welfare anymore and wants to know how much she needs to work instead, she's just going to have to work 20 hours at that wage rate of $10 an hour to cover the welfare. And then finally, for the last one, what is Tatum's total weekly income if she works 35 hours a week? So how much of this income is from welfare, child support, and labor market earnings? So she's working 35 hours a week, so 35 hours times her wage rate of $10 equals $350. We can see that since she's already receiving more than the welfare guarantees, she's not going to receive any welfare. But she is still receiving $100 from child support, so we can add $100 onto that to give us $450 of income. And like I just said, this $450, 0 is from welfare, 350 is from labor market earnings, and then $100 is from child support. And that is all that was needed for number 6. So I apologize. I was having trouble explaining some things today. Not really sure why, but hopefully you're able to follow along. If not, I do have past videos from other semesters up, so I might have explained things a little better in those lesson 4 videos, but hopefully this helped with your studying and that you have a better idea of what to expect on exams from this kind of material. So best of luck with your future studying, and I'll see you next week.